Okay. I'm going to record a solution to number 12 on the board, and then I'll post it on Canvas later so you can see it. But try to pay attention now too, because maybe that'll be helpful. Okay, so I'm going to try to remember most of what number 12 says, but if someone could help me with some of the numbers, like what's the battery voltage?
120.
Okay, 120 volts at the positive, 0 volts at the ground. Okay, what's the first resistor value?
50.
50 ohms. And then I've got two in parallel here, right?
Yep.
And what are their values?
75. 45.
Great, thank you. And then what's my last resistor?
50 ohms.
And what's the question?
Find the current going out of the power supply.
Okay, find the current going out of the power supply. So that immediately tells us we need to know this thing called the total resistance. Because what the battery is doing, it's providing current to an amount of resistance that is represented by the sum of all of these. So we should use the resistor addition formulas, but remember, we can't say that everything here is in series, and we can't say that everything here is in parallel. It's a combination circuit. So these two together are definitely in parallel with each other. And the way we know that is that they're actually hooked up to the same wire. Okay? Same wire there, same wire there. So to find the parallel resistance here, we use the formula 1 over R equivalent, and this is just for what's in the green. This is not the total resistance. Is equal to 1 over 75 plus 1 over 45. If I add those up, someone can tell me what I get for an equivalent resistance here?
0.94.
0.94?
Yeah.
Oh, no, wait, sorry, I meant to say, what's the resistance for these two in parallel?
8 over 225.
Does everybody have a number for that?
28.
28? Okay. You got 27?
26.
You got 26? Okay, well,
Yeah, 28.
let's call it 28. But
Oh, no, 28 for that one.
so let me just point out that this value, it makes sense because, I don't know if you recall, two parallel resistors, the total resistance has to be less than the smaller one. Is this less than 45? Yes. Okay, so this whole circuit could be thought of as follows. Could be thought of as a 50 ohm in series with a single 28 ohms, which is also then in series with a second 50 ohms. Okay? I've just replaced these two with a single 28 ohm resistor. Now I know that I've definitely got a series circuit because all the current that comes out there goes through all three things. So the total resistance here is 128, or 50 plus 50 plus 28. That is what's going to determine the current out of the battery. So the current out of the battery is equal to 120 volts divided by 128 ohms. What is it, 0.94?
Yeah.
0.94 amps. Okay, what's the next question?
How many joules per second of energy is the power supply giving out?
Okay, to find the power, we're going to use one of our three power formulas. Current times voltage is probably the best one because I know current and I know voltage, so I just say 0.94 amps times 120 volts. What does that yield?
112.5 watts.
112.5 watts, which is a joule per second. So we'll just say 112 joules per second. All right, next part.
Find the current going through the 75 ohm light bulb.
Okay, so this is where it gets a little tricky. We want to find the current through the 75 ohm bulb. And generally speaking, in these problems, when you want to find current, you just want to use Ohm's law and say V over R, voltage divided by resistance. But the question is, what's the voltage across this? And the answer is definitely not 120, okay? Because if you remember this whole concept of color coding a circuit, so let me just remind you, we'll call all of these colors 0. We'll call everything here 120, each resistor has to have a color difference across it in order for there to be in order for there to be current going through it. So this 120 volts has to change color across this resistor or become something else, like for example, blue. Anyways, the point, I've run out of colors, sorry. The point is, the voltage here can't be the full 120 because then you wouldn't have any drop across this 50 or any drop across that 50. All right, so that was kind of a poor explanation. How are we going to find the voltage drop across the 75? Well, there's a couple of ways to do it. Here's sort of a clever one. Okay? If we know the total current out of the battery, which we do because we solved for it, we can find the voltage drop across the known resistors. So I know I've got 120 volts here. I know I've got 0 volts here. If I'm going to push 0.94 amps through a 50 ohm resistor, there must be a voltage across it of I times R. So I would say delta V for the 50 ohm resistor, not the whole circuit, but just for the 50 ohm resistor, is the current I times R, which is 50 ohms.
47.
So this gives me, thank you, 47 volts. So I know that there's a 47 volt drop across this one. By symmetry, I also know that there's a 47 volt drop across this one. So if this voltage is 0, I know the voltage here has to be 47 volts. If this voltage is 120, true or false, the voltage here is 47. False. So what would the voltage here be?
120 minus
It would
47.
be 120 minus 47, or 73, right? This is because the difference here is 47, difference here is 47. So I've then calculated the drop across the 75 ohm resistor. And because it's in parallel, I've also calculated the drop across the 45 ohm resistor. It's 73 to 47, which is a difference of 26, right? So I've got a 26 volt difference across these two. So the current through the 75 ohm is the voltage across it, 26 volts, divided by the resistance. That, what is that, 0.35 amps. And then the current through the 45 ohm resistor, let's calculate it just for kicks. 26 volts divided by 45 ohms. That's going to be, anybody got a calculator? Go for it, Evan.
26.
Divided by 45.
0.58.
0.58. Now, bonus question. If I add these two numbers, what number on the board should this equal? If I add those two numbers,
Oh, the current.
it should equal 0.94. Does it?
Yeah, 0.93.
We'll take it. Okay? So that's how you do number 12.